Alright, here's 3 examples. We're asked to factor the trinomial. So what I suggest doing first is if you look at the last term, here we've got plus 2, positive 2. So list all the factors, numbers you can multiply together to get a positive 2. Well, you can do a positive 2 and a positive 1. You can do a negative 2 and a negative 1. Then look to see which one of those you can add together to get the second term in here. So you look here, and of these factors that we listed, which one of those can you add to get 3? And there you have it, the 2 and 1. So when you write the factor for this, we got a positive 2 and a positive 1. So the quantity x plus 2 times the quantity x plus 1 is the factored form of that trinomial. Alright, again, looking at the last term, listing factors that give you positive 10. You can do 1 and 10, negative 1, negative 10. You could do 2 and 5. You could do negative 2 and negative 5. So of those factors, now we got to look to see which one of those factors can we combine to get negative 7. Well, that doesn't work, that doesn't work, that doesn't work. Oh, this one does. Negative 2 and negative 5, when you put those together, do give you negative 7. So when you factor out that trinomial, we've got the minus 2 there and the minus 5 there. So we have the quantity n minus 2 times the quantity n minus 5 is their factored form for that trinomial. Alright, so here again, looking at the last term, listing factors that will give us negative 13. We have negative 13 and positive 1, and we have positive 13 and negative 1. Now, as we continue to look at that, we want to look to see, okay, when we look at those factors, which ones can we combine to get negative 12? Well, when we put negative 13 and 1 together, that gives us negative 12. So when we factor this out, we've got the positive 13 and we've got the negative 1. So the quantity w plus 13 times the quantity w minus 1 is the factored form of that trinomial. Alright, so if we want to solve this equation, we're going to first start by factoring. So I'm going to look at the last term there and list the terms or factors that we have. When you multiply them together, that give you negative 14. We can do negative 14, positive 1. We could do positive 14 and negative 1. We could do negative 7 and positive 2. And we can do positive 7 and negative 2. Now, as you look at those, which ones add together to give us negative 5? That doesn't work, that doesn't work. This one right here is going to do it. So we're going to put, alright, and we got minus 7 goes there, plus 2 there. This is an equation and equals 0. So here basically each of these parentheses represents a number. So either all of this could be 0, because anything times 0 is 0, so you can say either m minus 7 equals 0, or all of this could be 0. One of those two things in the parentheses have got to be 0. So as you do that, then if you solve this equation here, m would be 7, or if you solve this equation, m would be negative 2. So our two solutions for this particular equation is m equals 7 or m equals 2. Alright, so we want to find the zeros of this polynomial function, which means we want f of x to be 0, so I'm just going to write f of x is 0 there, and now this particular problem looks like one of the ones we just did. So we're going to start looking at 18 here and list all the factors you can put together to multiply and get 18. We got 18 and 1, you've got negative 18, negative 1, we've got 6 and 3, we have negative 6 and negative 3, we've got 9 and 2, we've got negative 9 and negative 2, and then as you start going through that, then look at that middle term there, and look to see which one of those factors, when you add them together, give you 11. Well, that gives you 19, that gives you negative 19, that gives you 9, that gives you negative 9, this gives you 11. So we now have this being factored out like this, and we've got a positive 9 and a positive 2. So what that means is either x plus 9 needs to be equal to 0, or x plus 2 needs to be equal to 0. So we've got x plus 9 equal to 0, or x plus 2 has to equal 0. So here x would be negative 2, and here x would be negative 9, and those are our possible zeros. Alright, so here you want to solve this equation. I'm going to simplify it and move some things around so that it's set equal to 0. So what we're going to do is we're going to take this, get rid of the parentheses first. We've got this negative 10. I'm going to distribute it and multiply it by d, and that gives me negative 10d. And then I'm going to take the negative 10 and multiply it by negative 1. That gives me positive 10. I'm going to bring down the d squared, and this still equals negative 11. Now as I do this, I want to get it equal to 0, so I want to get rid of this negative 11 here. So I'm going to add 11 to that side. What you do to one side, you have to do to the other. And when you do that, we have d squared minus 10d plus 21 equals 0. Now we're going to look at this and list some factors that give you 21. You can do negative 7, negative 3, positive 7, positive 3, 21, 1, negative 21, and negative 1. Of those, then you want to look to see, okay, which ones can we combine to get negative 10? Well, negative 7 and negative 3 do give me negative 10, so when we factor this out, I'm going to have my d's here. I got the negative 7 there, negative 3 there, it's equal to 0. That means either d minus 7 has to equal 0, or d minus 3 has got to equal 0. So d ends up equaling 7, or d will equal 3.